So student, now in today's lecture we are going to see the information about dielectric. Now in the previous lecture we have seen that there is the capacity of a conductor will goes on increasing by inserting the dielectric. Now what this dielectric is there? This dielectric is nothing but the insulating medium. Now what is the function of this dielectric? This dielectric can store the maximum energy inside the capacitor. Now this dielectric are of two types. One is nothing but the polar type of dielectric and another is nothing but the non-polar type of dielectric. In that, now we are going to consider the first as a polar type of dielectric. Now what these polar molecules are there? The polar molecules, now whenever we are considering a molecule means it has a positive charge as well as it has a negative charge. So in the polar molecule, the center of positive charge is not going to be coincident with the center of negative charge. That type of molecule is to be called as a polar molecule. Now, suppose I can consider the example HCl. In that, what is the thing? H is a positive molecule. Cl is a negative molecule. So in HCl as a polar molecule, what happens? Center of H positive will not coincident with center of Cl negative molecule. So the positive molecule and negative molecule, their centers are not coincident with each other. And when they are not coincident with each other, we can say that the polar molecule does not have a symmetrical shape. Now such polar molecule are shown here as one of the example as a H2O. So H2O as a polar molecule has two H molecule and one oxygen molecule. So in between oxygen molecule and hydrogen molecule there is a bonding. Again here is a second bond and in between that two bonds there is an angle which is nothing but 105 degree is the polar angle. This angle is to be called as a polar angle. Now such polar molecules whenever are going to be kept inside the electric field, then what happens? So that we are going to consider under the topic as the effect of electric field on the polar molecule. So now first we are going to consider that is if electric field is not applied there, means electric field is zero. Now when electric field is zero, so see in this diagram I have shown here polar molecules. So here is one polar molecule which has a positive molecule as well as negative molecule. So in the absence of external electric field, the permanent dipole of the molecules are orienting randomly. Now dipole means what? This is one molecule. If I am considering HCl, so H is positive, Cl is negative. So positive and negative, they are forming a dipole. So this permanent dipole molecules, they are randomly orienting, randomly moving inside the plate. So that's why the net dipole moment of this total dielectric medium will become as a zero because their directions are not fixed, they are moving randomly. So as they are moving randomly, the net dipole moment of this polar molecules will become zero. But when we are going to apply electric field, so when electric field is applied, then that dipoles will start rotating themselves in the regular fashion. What is the meaning? Regular fashion means if electric field is there, so one side is positive, another side is negative. So what happens? Polar molecule, negative of polar molecule will get attracted towards the positive of electric field and negative of polar molecule will get attracted towards the positive of electric field. So there will be a opposite attraction, means polar molecule negative will get attracted to the positive of electric field and positive of polar molecule will get attracted towards the negative of electric field, and that is to be called as a regular fashion. So when electric field is applied, the dipoles start rotating, orient themselves in the regular fashion and hence in that the dipole moment will get induced. So that now what happens next? Next is nothing but your non-polar molecules. So in non-polar molecules, again we can say that a molecule which has a positive charge, which has a negative charge. So let's consider, here is the example I have taken here I have taken one of the example, N2. N2 means 2 N molecules. 2 N molecules. So what happens? The center of positive charge will coincident with the center of negative charge. That type of molecules are to be called as a non-polar molecule. So as the positive molecule, positive charge center is coincident with the negative charge center, therefore such non-polar molecule has a symmetrical shape. Now such non-polar molecules, whenever we are going to be used under the electric field, then what happens? That we are going to consider under the effect of electric field on non-polar molecule. So now here initially in this first diagram I have shown that electric field is 0. Electric field is 0 means what I can say? There is absence of external electric field. If external electric field is absent, then the effective positive and negative charges are coincident already, and hence dipole moment is not formed. So dipole moment P will become 0. Why? Because their centers are exactly coincident with each other. When electric field is applied, so electric field is applied means what? The positive of non-polar molecule, positively charged non-polar molecule will get attracted towards the negative of electric field, and positive of non-polar molecule will get attracted towards the negative of electric field, and vice versa. So when electric field is applied, the positive charge are pushed in the direction of electric field, and the electrons are pulled in the direction opposite to the electric field. Meaning is what? Electrons means negative charges will get attracted towards the positive of electric field, and positive charge of non-polar molecule will get attracted towards the positive of electric field. So there will be a separation of positive charge and negative charge. So due to that separation of effective charges of positive and negative charges, there will be a formation of dipole. So there will be dipole will get formed. So from polar and non-polar molecule, these dielectrics are formed. Now what is dielectric? Already I have told you, that is dielectrics are nothing but the insulator. They are nothing but the non-conducting medium. That's why they are called as your dielectric. So this non-conducting material in which induced charges are produced on their faces on the application of electric field are to be called as your dielectric. So this is the definition of dielectric. Now some examples of dielectric I have given here. Like air molecules are dielectric, H2 molecules are also dielectric, glass film is a dielectric, mica sheet is a dielectric, paraffin wax is also act as a dielectric, and transformer oil is also a dielectric. Now from that dielectric we have to concentrate on the case which is to be called as a polarization of dielectric. Now polarization of dielectric means what? That we have to consider. Now when non-polar dielectric slab material is subjected to the electric field, so dipoles are induced due to the separation of effective positive and negative charge. Just now in the previous slide, if you are remembering, in the previous slide we have seen that is in presence of electric field, the positive of non-polar will get attracted toward the negative of electric field, and negative of non-polar will get attracted towards the positive of electric field. Means there is a separation of charge. So same separation of charge will happen here. So what I can say that E0 is the applied electric field, actual electric field applied, and EP is nothing but the induced field due to dielectric. So there will be a formation of, so see here you are getting a positively charged plate, and here you are getting a negatively charged plate. So your lines of force will start from positive charge, it ends on negative charge. So this is to be called as your electric field direction from positive charge to negative charge of the plate, which is nothing but E0. And inside that two plate, one plate is positively charged, another plate is negatively charged, and inside that there is a dielectric. Now this dielectric is nothing but non-polar molecules. So see this, non-polar molecules are arranged here. Here is the negative of non-polar will get attracted towards the positive of electric field, and here is the positive of non-polar which will get attracted towards the negative of plate. Have you getting this? See there, all these positive of non-polar molecules get attracted towards the negative of electric field, and here all negative molecules of the non-polar molecule which will get attracted towards the positive of electric field. Means there will be oppositely the charges will get attracted, and hence due to this dielectric there will be a formation of electric field which is nothing but as a EP. So this EP is nothing but the electric field induced due to dielectric. So see now in the diagram, your E0 direction is from positive charge to negative charge of external magnetic field. EP direction is positive of non-polar molecule to negative of non-polar molecule. So this EP direction, E0 direction, they are opposite. Therefore net field En is nothing but E0 minus EP. So now electric field will get reduced when your dielectric slab will get introduced, and therefore now your dielectric constant will be given by K is equal to original electric field divided by the net electric field. So using that you will get it the effect of dielectric. So now due to that effect of dielectric, see here also I have shown that here is a positively charged plate, here is the negatively charged plate. So lines of force will start from positive to negative. So this is your original electric field E0, original electric field E, and ये आपका dielectric medium है जिसमें आपके polar non-polar molecules opposite direction में introduced होते हैं. So its direction will goes on changing. So like that manner you can study the effect of charges. Here also I have shown induced surface charge on dielectric develops the polarization. So see here is the actual direction of electric field, and this is the direction of electric field due to your dielectric material present. So E0 is the induced electric field and E is nothing but the original electric field. Therefore net electric field will become E minus E0. Therefore net electric field will goes on reducing, and when electric field will goes on reducing, automatically there will be the effect on your capacity of conductor. So how there is a reduction of electric field due to polarization of dielectric? When dielectric is placed in the external electric field, value of field inside the dielectric is less than the external electric field due to polarization. Now what is polarization? Okay, just see here. This is the polarization concept. Polarization is the vector measures the degree of polarization of dielectric. It defines the dipole moment of unit volume in the polarized dielectric. इसका मतलब क्या है? Just see here. See here. Here is the dielectric medium, non-polar molecule. इसका जितना volume है, this is called as a volume of dielectric. So your polarization is what? Net dipole moment. Net dipole moment means P. P divided by this total volume of this space occupied by the non-polar molecule is to be called as a polarization. So this is nothing but your polarization. So SI unit of polarization is what? C upon meter square. Therefore C meter raised to minus 2. Now this dielectric has a strength. Strength means what? Dielectric strength is the maximum value of electric field intensity that can be applied to the dielectric without its electric break. So that is to be called as your strength of dielectric. And using that strength of dielectric, now we can consider how that dielectric will goes on reducing. dielectric effect will goes on reducing. So that is shown here. In the presence of external electric field E0, the center of positive charge on each molecule of non-polar dielectric is pulled in the direction of E0. Whatever I have explained, that only I have written on this PPT, and from that I will get it. Dipole moment per unit volume is to be called as a polarization. And then I am getting formula polarization P is equal to psi E, where psi E is electric susceptibility. So now we can stop. Next part we can see in the next video.